the way that IT operates. However, the change is actually so much bigger than that, and it includes a complete transformation of the way that IT is being used, operated, and actually the expected business outcome of the people that are operating in this area. Why is that? Well, because if you think about it, IT is still a pretty young kind of industry. If you want to learn about where IT is going, you need to look at industries that actually have matured way more than IT. Think about, for instance, manufacturing, where you see car makers that actually have made this big shift in the last several years, moving from doing every bit and piece of their cars and assembling their finished product by themselves to a logic of a supply chain. Why they did it? They did it to reach bigger economies of scale, to be much faster, and to actually work with specialists that could help them actually aggregating all these different, if you want, components into a finished product. So if you think about the typical car manufacturer today, they do the engine, they do the design. If you were, for instance, Ferrari, because I'm Italian, they also do the leather seats. It's part actually of the experience. And then they actually manage the brand. But of course, the engine of the car, the components of the car, the brakes, the plastic of the dashboard, the glasses, etc., come from somebody else. It's still a car that carries that brand, but it's aggregated, it's actually built much, much faster. Why am I telling the story? Because fundamentally IT is going into a similar direction. It's going into a direction of a supply chain. And actually you see this in this new cloud world more and more. If you think about the fact that from an initial wave where fundamentally people were going and buying from a single provider, more and more you're starting seeing what we already saw during the rise of the internet itself, where people do not want to feel constrained in buying from a single ecosystem anymore. When did we hear that in the past? Well, we contend at Cisco that what we're seeing these days is extremely similar to what we saw during the rise of the internet. Think about what happened during those days. Well, during those days, we had a variety of players that were pushing their proprietary technologies, and you will remember some of these guys, right? If you think of IBM, you can think of SNA, Novell IPX, you remember digital technology, you remember Apple Talk, and you remember Banyan Wines and a lot of other protocols. All of this was really a set of technologies that wouldn't allow really interconnection of all these environments, which is what ultimately customers wanted to do. What happened then? Well, what we saw was the rise of open source, was the rise of the internet protocol that started interconnecting all these different worlds. Not only interconnecting all these different environments, but IP did something else. It delivered new applications, new capabilities. Emails at the time were actually new applications, especially across the boundary, and then the big deal, which was actually the World Wide Web. The web browser actually came to us in a completely new, different way of actually getting access to content was then made possible. Then we know how the story ended. IP penetrated all these different environments, and it ended up fundamentally conquering everything. And here we go. After several years, we got the global internet that went through a number of different phases. Now look at how similar this is to what we see today in cloud. You have a wonderful world of many clouds, all of them pretty much isolated. All the clouds that you see over there in the picture, in the slide, are actually all different. They are built in different ways. They use different APIs. They very, very rarely are capable of working together. But the problem is that from an end user standpoint, from an IT standpoint, people want to use all these different things together. They don't want to see walled gardens because they want to see every cloud for what that cloud is actually good at delivering. So at Cisco, we see our future as really centered around this concept of the intercloud, which, if you think about it, is actually not really a Cisco branded invention. It's just the natural evolution of the internet. In the good old internet, you carry packets, okay, IP packets across a huge number of networks. In this new world of intercloud, you actually move workloads, which is network compute and storage, across multiple clouds. So it's just a natural evolution of the internet in this cloud direction. And this is where we see the company really going. This is what Cisco is really good at doing, is interconnecting anything to anything else. And this is where we see ourselves really playing a very key role. Now, all of this is happening into the market very, very fast. I mean, the advent of this multi-cloud world and hybrid cloud itself, mixing and matching on-prem environments with cloud environments, actually is materializing not without pain. In the last several engagements that Cisco has got with very large customers, around a couple of hundred customers in the last period, we kept putting the question to the leaders of the IT organization: how many cloud services do you think, Mr. CIO or head of VP infrastructure, how many cloud services do you think you're actually having in your premise, in your organization? And the answer is normally X. Well, guess what? Thanks to a couple of software probes that we put into the network, this is a Cisco service that we actually sell in the marketplace, we discover, and this is a real number, that the real number of cloud services going on into an average medium to large organization is actually 5 to 10 times bigger than what IT believes. Why is that? It's pretty simple. It's because with cloud, the line of business, like the sales organization, the customer services organization, or the marketing organization, now have a different mean of fundamentally buying what they need as a service, pretty much bypassing the IT organization. Now, this actually has been probably the first phase. We're now seeing a second phase of this trend, whereby there's more and more collaboration between the IT organization and the line of business. In fact, there is some market data that shows that a vast number of cloud RFPs here in the United States are driven in collaboration between the line of business leader and the IT leaders. Why is that? Well, it's that because when you buy cloud services and you're not the IT organization, you may do some pretty bad mistakes in handling this kind of services, right? If you buy from box.com, great service, by the way, and you don't have the management of the single sign-on in your organization, you can put the information of your company at stake when you exchange files between the employees, right? So you need to govern this kind of solutions through a centralized entity. The other big problem that actually we don't have the time to discuss about it, but it's a very big deal, is actually the fact that with the advent of cloud and a number of clouds being operated by an organization, the data is going to get spread all across the board. So rebuilding consistency of data, what is actually called data virtualization more and more, the build out of a single data model, that will take center stage. It's going to be a big, big deal moving forward. So if you think about the impact on the IT organization, this is actually pretty enormous. It's not just a budget impact and a technology impact, but more and more is becoming actually a big deal of human transformation. There's a huge human impact in all of this, because a lot of the jobs in IT were actually created over the last several years to act in a completely different world than the one that we're going to. One of the things that you see some of these highlights, but fundamentally, if you think about it, summarizing everything in few words, more and more, because IT is moving to a supply chain, the key question that will need to be answered by an organization is, given a certain service that the business wants to implement, okay, do you make it? Do you literally code it yourself or with the help of your developers, or do you buy it from the cloud? And you need people that really understand the full extent to the complexity of building an application or a service inside an organization to make that call. Because if you don't control, for instance, if you're an application developer and you don't understand vulnerability assessment, you may miss the amount of investments and costs that securing an application may actually take, as well as you may not actually have clear that you will probably need a network update, a network enhancement. You may need more bandwidth, you may need more capacity, you may need new load balancers, firewalls, etc. to run that kind of service. So more and more, you will see in IT organizations the advent of people that understand the full stack, okay, and not just a piece of the stack, not just the storage, the network, or the server. They will have to be more and more aware of the impact of building these new services. Now, that's why we are actually pitching the intercloud, if you want, to the industry at large. And as I said, it's not a Cisco invention. It's actually what is going on out there. It's an academic term. You can actually Google it, and you will find it, or you can find it on Wikipedia. It's cloud of clouds. Why is so important? It is important because from an end user standpoint, what people really want to do is to use all these disparate clouds, including the private cloud that they have inside, more or less private cloud, pretty much virtualized kind of environment today, and more people are building services portals on top of this virtualized infrastructure. What you really want to do from an end user standpoint is harness all of this power together as if it was coming from your own data center, from your own facility, like, of course, a service catalog that you publish to the rest of the business, or you publish to your constituencies. Okay? Imagine if you could actually publish a set of services that are coming from either your on-prem infrastructure and application portfolio, as well as from the cloud with a single front end, how powerful that would be. Now let me take this to another level. And imagine if you had the possibility of using these clouds very, very flexibly to, for instance, migrate workloads across different clouds and bringing together your network and security policies, which is really where the complexity of doing this job actually resides. One of the things that people need to do today, before we came up with a lot of the technologies that I'm going to show you in a moment, every time that you move a workload, you actually need to change IP addresses, security policies, it's VLANs. It's a very, very complex job to do. Now imagine if you could do all of this automatically, if you could actually automate the fabric, not just in your cloud, but across the clouds. And that's the level of control that we're looking at delivering, and it's not just single direction, but it's bidirectional. Now you may think, is this like a technology nuance? No, it isn't. Let me, for instance, make the example of rapid application development. A lot of people are actually opening an account into Amazon and Azure today, developing an application, and then a lot of them are discovering that some of these environments are actually built very much for spiky workloads, not for workloads that are actually running 24/7, generating a lot of traffic, and then you'll see the cloud bill going very, very much high. There are quite a lot of companies that are using the cloud for test and dev, either for disaster recovery as a service and capacity bursting, etc. So the two clouds really need to work together, and that's why these technologies are so important. And the level of simplification that we're bringing in this game, that I'm going to go through in a moment in the technology section, is really what Cisco brings to the table, because it's a big network complexity that we're resolving to make all of this possible. And again, this is fundamentally hidden behind this concept of unified catalog. Now, how do we do this? This is what really the company has been so active in the past months. If you've seen the announcements that we made in the marketplace starting from March last year, when we really announced the evolution of our strategy, where our belief, and this is a bit of the infographic really of the Cisco strategy, our belief is that this world of many clouds need to get together, and that fundamentally the end game is not that all the workloads are going to migrate in one place, but workloads are going to reside in multiple clouds. A lot of enterprises are going to have their premise infrastructure forever, right? Much like it happened with the mainframe. If you think about it, I mean, even with the advent of client server, a lot of the traditional stuff never really went away. New applications were built in addition to the existing ones, and this is what we're going to see more and more. So there's going to be a distribution of workloads and applications across the board. Enterprises are going to have theirs, and then they're going to get access to Cisco Power Clouds that can deliver additional capacity. They can get to any of the other providers that you see over there, like Azure, like Google and Amazon, and so on and so forth. And the most important, something that really nobody else is talking about in the industry, is how do you make all of this working seamlessly across the board. Many other players are saying my cloud is better than the others. We're saying there's a role for each of these clouds. It's actually the end game is giving the customers control to access all of these clouds when they want and how they want. Okay? So if that's what you think is fair game, then imagine again the possibilities. Imagine having a service catalog that actually gives you the ability to pick the services from this big ecosystem. How is this going to happen? Well, imagine if you could have a marketplace or a service catalog that's published and not just coming from one of these players like Cisco, but it's coming from Cisco and our partners, which is the case that you see over here with some of the names that are pretty recognizable on the slides. Imagine if all of this actually will work seamlessly with your internal catalog on the right-hand side. That's what you do, right, as an IT organization. And now, imagine if, as simple as drag and drop, you could actually import services from the public cloud to your internal cloud. And you could do it securely, seamlessly, and in an open fashion, an open world. Not just for services running on a single hypervisor, as other players in the market are saying. Okay? Not for services running only in just one cloud, as other players in the market are saying, but running seamlessly across this world of many clouds. That's what we're in the market to do. That's actually where we're going. So what I'm going to do now is actually taking you to some of the enablement technologies that make all of this possible. And I'm going to start by saying that actually the thing that you saw before, you saw a Cisco cloud, is what we're building actively right now. That's where the action of this last few months has been. We've announced big partnerships, the latest ones with Deutsche Telekom, with Equinix, with British Telecom, and several other partners, where with some of these players we're fundamentally extending literally the fabric of this intercloud. So Cisco is building our cloud as an intercloud, and we're connecting all of this to every other cloud. Does you remember the internet? This is how the internet was built. The internet is actually a network of networks. The intercloud is a cloud of clouds. And the end game is making this work seamlessly together moving forward. Now, our vision, so from a technology standpoint, and you see the Cisco cloud over there, is just one of the clouds. We're not telling customers you should drop any other cloud provider. We're telling, we're going to build this cloud to deal with very complex kind of issues. We're going to go for heavy-duty workloads. For instance, we just released a service, which is a hybrid infrastructure as a service. It's not a vanilla service. You actually buy a service that has both the on-prem component and the component in the cloud. And all of this actually in our cloud is supported by OpenStack. Why OpenStack? Because if you follow the line of thinking until now, you understand that we're gonna build all of this based on standards. And there's no question that OpenStack is the IP protocol of this next cloud wave. Now, does it mean that the other hypervisor or virtualization technologies don't work in this scenario? Not at all. Because much like during the rise of IP, all the other protocols were actually working and sustaining ongoing applications. But make no mistake about it, when you look at big data, analytics, and some of the new things that are made possible by all of this, or Internet of Things applications, they're actually being built on different environments, especially hypervisor technologies, than what actually IT organizations have been operating until now. And again, you're starting seeing that the analogy between the internet and the intercloud really holds. So let me go into some of these capabilities, which at this point it should be pretty obvious. As I said, workload portability is very key. Hypervisor independence is key. I mean, users should not be constrained in using one hypervisor. Why? Right? You want to use VMware, you want to use Microsoft, you want to use KVM, and then using OpenStack. You should be able to use all of this together and handle by yourself the mix of these things, as well as how you want to do application migration across the board. You need a policy-based control to make all of this happen. Why? Because if you look at all of this and you think that you can operate and you can really take the most out of this by using common good old procedures to manage your underlying networks, you're wrong. You need big-time fabric automation to make this happen. And you need to have an infrastructure that is actually application aware. Otherwise, it's never going to work, right? It's not just about fat pipes. It's about pipes that understand the kind of application that is running through and behave accordingly to service quality, security, and so on and so forth. The other thing is that it's all about partner ecosystems. Nobody can do this job by themselves. Just nobody. The innovation is in the OpenStack community. The innovation is in the ecosystems of some of these public cloud providers. The innovation comes from across the board. That's why we're in market to kind of tear down a lot of these walled gardens and level playing field kind of scenario that we want to drive out there. I mentioned about data virtualization, open standards, and this is where I'm going to go now in the next presentation. Now, I'm going to start from the impact that all of this is creating around the data center, because clearly data centers are the key to all this game, right? That's where fundamentally you have the computing capacity of the cloud. But if you think about it, something really interesting is going on. And that is that thanks to the advent of new applications, the data center is being stretched in two directions, okay? On one side, you have applications that I'll show you in a moment that require more and more edge-scale computing, meaning having computing all the way down to a branch office or local location. I was with a big retailer here in the United States, and they were telling me that the number of sensors they're going to have into a store is going to be mind-blowing. Now, if you think that you can concentrate all of that into just one data center, well, think twice, right? You need capacity into the store to do it. Imagine if tomorrow we're all going to start, buying some of these interesting glasses that you see around, or using video applications of that nature. The amount of traffic that comes into the network is going to be just unmanageable. You got to have analytics. You got to do cluster analytics very, very close to where these objects are actually built, which is why Cisco just actually launched IOX, which is our way of implementing what is called fog computing. What it means is fundamentally pushing computing capacity all the way down to the aggregation level where users are accessing the network, right, into switches, routers, access points, and the likes, well before you get into a data center. On the other side is clearly cloud scale computing is fundamentally taking the game from the customer data center all the way into the cloud. And clearly the two things need to work together. So you see these things as kind of stretch, and you need to have specialized solutions and architectures to actually make this work. Now, I said some of the reasons why this is happening. Let me just materialize them. You can think of IoT like connected sensors, smart objects, some implementations like smart cities, for instance. We've been talking about the city of Barcelona from the Cisco standpoint and the kind of incredible example that it makes in the marketplace. Mobility, location-aware services, rich media, etc. And of course, branch office, remote sites that I just mentioned with the retailer example, but you can think of many of these kind of examples in oil and gas and many others verticals. Now, all of this creates the need of edge-scale computing, getting very, very close to the edge of this application. Because in the end, what you need is to have an intelligent edge that pumps all this, first of all, start analyzing all this information and then pumps all of this into the data center. Well, at the same time, once you have all this information centralized, you need scale-out application, typically big data and cloud. You have trend analytics, you have real-time price optimization, for instance, is becoming a big deal. If you look at the war between the retailers in the marketplace, recommendation engine, fraud detection. Of course, if your credit card is being used somewhere and your mobile phone is not there, why not raising the flag that there's something wrong going on? Things of this nature. So clearly, to have all this kind of intelligence, you need to use cloud scale. Think of video gaming. Think about applications like this. They don't scale accordingly to the good old ways of building applications with a 3-tier model that you guys know better than me. They actually have pretty unpredictable kind of requirements. Capacity management is actually becoming a big deal in this cloud world. So this is really happening that way. And this is actually what you need. Fundamentally, you need to connect to these new opportunities on one side, and you need to, on the other side, have deeper insight, and you need to connect these two worlds. Now, the impact is really you need specialized platforms to pull all of this together. Now, this is a very, very important thing to say, because so far, what I talked about is how Cisco is really busy, and we've been busy in this past few months, and we're going to be very busy in the next months and years to build this concept of the intercloud. But then you may think, okay, how do I connect to this? Because you're talking about this kind of big internet thing, and much like the internet, you need routers to connect to the internet, right? Now the question you may have is, okay, you're building this cloud of clouds, how do I connect to that? And that's where the developments that we've done in this past years, starting from the advent of unified computing, where we really rock, from an industry standpoint, we rock the market with the development of our UCS platform, whereby we pulled together our server technology, we pulled together network and computing, because we saw that we couldn't go beyond the server form factor when virtualizing the infrastructure. You can virtualize only to a certain extent. The extent that the box actually allows you to do. You cannot go beyond that point. So clearly we needed to extend the computing across the network fabric, and that's what we've done. That's what we've done building the computing technology. But then we said, okay, we need, of course, to join forces with some of the storage players out there. And we formed some of the very well-known joint ventures, in one case, like in the vBlock case, or partnership like FlexPod, and then directly with EMC with vSpecs. We did the same with Hitachi. Lately, in September, we launched a similar solution with Red Hat, called Integrated Infrastructure for Red Hat OpenStack, UCS Integrated Infrastructure. Now, why am I telling you all of this? Because clearly this is what customers have on their prem. What you need is software that fundamentally takes this infrastructure and actually connects it to the intercloud. And the message is that thanks to these technologies like ACI, which is fundamentally a Cisco's version of SDN, and the intercloud fabric, which is a really cool new product that I'll show you in a moment, we're able of extending, one, the policies that the infrastructure is setting within their own perimeter and extending these policies to the cloud. And two, once this policy is extended, actually taking the workloads into these environments, because at that point the enterprise controls, so to speak, the host cloud according to their rules. And that's really, really cool. So let me enter into this for a second. The first bit is actually the fact that a common policy model, as I said, is required. Now, some companies out there are saying the same thing. Pity that they're talking about just software-defined data centers. And software-defined data center is a great concept, but the thing is that that's where the application runs. What about the users that need to connect to those applications? What about the objects, the sensors, and the processes, and all the other stuff that needs to connect to it? It's pretty clear that when you do this level of automation, because we're all saying the same things in the industry, the difference is Cisco is actually telling that you need this level of automation, not just in the data center, but you need to extend it across the WAN access where people are coming in. And then you may set your policies. Because, for instance, you may be happy in one company if one of your employees is accessing your financial data through a third-party hotspot, okay, say from Starbucks. Some others may not be happy about it. Some others may be more conservative and saying, you know what, I'm not going to allow the access to my most important financial data when somebody is coming outside of my perimeter. That's company decision. And all of this is only possible if you control the end-to-end of this game, not just the data center, which is actually what we're doing. And by the way, the same goes for the cloud. Because as we demonstrated, for instance, at Cisco Live in San Francisco, our flagship event just some months ago, we demonstrated how the Cisco ACI fabric can actually work with the Azure Pack, right, the SDK, and you can actually export policies from the enterprise premise into Azure by actually taking your level of control into Azure and imposing your policy into that kind of cloud. Now, the second piece of the equation, common policy model, is number one pillar. The second big deal is the intercloud fabric. The intercloud fabric is new software that is now orderable from Cisco, and the intercloud fabric stands to the intercloud like routers stand to the internet. In the internet, you carry packets across autonomous systems by using routers. In the intercloud, you use the intercloud fabric, which is actually hypervisor agnostic and cloud agnostic. So the intercloud fabric can take any workload, network, compute, and storage, and move it to fundamentally any cloud. The product understands the APIs of Azure, Amazon, as well as Cisco Power providers, and you can fundamentally decide where are you going to put your workloads and when are you going to take them back. So this gives you what I think is the most important attribute of this old Cisco game, which is choice. A level playing field gives customer choice. You're free to decide where are you going to put your applications, one direction and the other direction. Because again, there are a lot of use cases that provides for this kind of capabilities. Consistency, because with one interface you can actually handle different kind of environments, you don't need any Azure or Amazon specialist. You have one interface, and you need a subscription, and you're ready to go to move your workloads across the board. It gives you control, of course, and it gives you compliance. That's the killer app. Because the question is, some of these workloads are going to go under the scrutiny of the wider organization. Some workloads, for instance, if you're in Europe or in several other places across the world, cannot be moved outside of the border of that given country. If you go to Germany, you cannot move any data outside of the German border if it's actually under the data sovereignty rules of Germany. And the same goes for most of Europe, I tell you. And it's the same for many other countries. So compliancy is a big deal. And so with a system like this, with software like this, you can fundamentally give users a way not to make a mistake. They're being given a GUI that, based on the type of workloads that they're managing, is actually telling them whether they can go or they cannot go into some of these clouds. Okay? That's very important, because fundamentally what you need to do is wiring your business logic into the technology implementation. You cannot allow users, either internally into IT or in other departments, to put their workloads wherever they want, because that's not how it works. Okay? There's a guidance that the IT organization is providing here. So what's the end game? The end game, it doesn't really matter what your strategy is. Whether you're running completely private, or you're running from a managed service, you're going to a hosted provider, or you go full-blown public cloud, it doesn't really matter. You will have to do two fundamental things that Cisco technology is actually giving you. The first one is you need your policy model to be reach literally into these environments, because you have to be in control, right? Not the service provider. You have to be in control. And the service provider needs to give you that kind of flexibility to accept your policy. If you have certain kind of firewall rules, if you have certain kind of ways of dealing with your routing or your switching, etc., that has to be actually accepted by the provider. And these technologies can actually give you that. And second, after you actually impose your policy, you can move your workloads around. If you have these two fundamental capabilities, you're working with open standards and you're hypervisor independent, what fundamentally you are getting is the possibility to extend your infrastructure while maintaining control and governance of this extended infrastructure, which is ultimately what people want. Okay? People want to actually get to the cloud by retaining the control. So in the end, what are the benefits for a corporation, for a company, for a developer, etc., in going in this direction? Well, these are the benefits. First, with an approach like this, you have visibility about what happens. You have a unified way of doing your workload management, and you can retain the control of all of this. Second, you achieve very, very low cost. And it's not just because you work with facility providers, but because you can use the best cloud for the best application. In the end, what you want to do, again, is actually using the best mix of cloud. Think about it. We talked about the supply chain. This game boils down to a sourcing strategy. You have a portfolio of things that you need to do. Who's giving you the right sources and infrastructure to support those services? It's just counterintuitive that a single player will be able to give you all of this. This is already a world of many clouds, and that's fundamentally the supply chain of the next generation IT, which is a very much of a faster kind of IT. Increase control, because the world is going towards a brokerage model. But the ultimate broker is not outside of the company, it's inside the company. IT can regain center stage, and IT can actually be the ultimate broker of these services, not getting bypassed by the business, but becoming more and more relevant to the business and acting as a broker of services and making well-educated decisions about a given service can actually be and should be sourced by the internal organization, or has to be acquired from the cloud. Okay? And then, of course, looking at the data implication, the security implication, and pulling all of this together. Increasing business value, because clearly this is the best way of making sure that you're going to be faster and faster. I mean, clearly every company is becoming a technology company, even when you're not. Even you are in very traditional kind of sectors and verticals, technology is enabling new business models to leapfrog competition. So clearly, business value is related to the adoption and the usage of technology to become faster and to beat your competitors in the marketplace. And finally, the other big deal is about risk. Think about how many times an enterprise will migrate to cloud. One, maybe two if you have a very big company and you do things like in stages. But the risk associated to this is pretty big. And clearly this is a way, this kind of strategy that we're pursuing with this intercloud model, which is a very partner-centric model. It doesn't just come from us. It's a cloud of clouds. With this model, you can actually find help for your needs, and you can find partners that actually do this every day. And they don't do it just for a cloud, but they do it for a number of clouds. So as you see, this is a very, very differentiated play that we have in all this game. It's not about saying that our cloud is better than everybody else. It's about specializing the cloud, but then the ultimate game is pulling all this cloud together in the intercloud. And that's what we're fighting for. It's not a Cisco thing. It should be everybody's interest. Thank you very much.